Dive into a really fascinating story from the history of computing. It's about a time when everything was breaking, a massive crisis that actually forced the industry to figure out what good software even means. It's a story of chaos, failure, and the brilliant ideas that came out of it all.
So let me ask you something. We've all dealt with a buggy app or a website that just doesn't work. But what happens when the projects behind them go completely, totally off the rails? And I mean, they went wrong in a big way. We're talking spectacularly, expensively wrong. In fact, this period of widespread failure happens so often that it actually got its own name.
So let's start there. Let's take a look at this era, a time that we now call the software crisis, when the way people were building software it just broke. It couldn't keep up.
Here's the textbook definition. You see, as computers got more and more powerful, our ambitions for what software could do just exploded. But the way we were actually writing the software, it didn't change. The complexity was shooting through the roof, but the tools and the processes were stuck in the past. It was, a perfect storm for total disaster. And wow, what a disaster it was. Just look at this list. Projects were always late. They were always way, way over budget. The software you actually got was slow, it was buggy, and half the time it didn't even do what you needed it to do. Sometimes, after all that money and all that time, you got nothing. The project just failed. And the code itself? A complete mess. A tangled nightmare that was basically impossible to fix or update. Okay, so to really understand how they got out of this mess, we have to look at the old way of thinking, the really flawed idea of what made a piece of software good in the first place. This was the old way. Fitness of purpose. It sounds simple, right? Does it do the thing it's supposed to do? If a car drives you from point A to point B, great, it's a quality car. If a fan blows air, it's a quality fan. Simple. And this right here really gets to the heart of the problem. For a physical thing, like a car or a machine, that fitness for purpose idea works just fine. But for software, it turned out to be a terrible way to measure quality.
So that's the big question, right? Why does this super simple definition completely fall apart when you're talking about code?
And these 2 points are just perfect examples of why. Think about it. You could have a program that technically does everything it's supposed to do. It checks all the boxes. But the user interface is so confusing that nobody can actually figure out how to use it. Is that a quality product? No way! Or what about software that works perfectly? Today. But the code is such a tangled mess, a total spaghetti monster, that the second you try to fix a bug or add a feature, the whole thing just crumbles. That's not quality either. So the industry had to face facts. That old, simple definition was broken. They had to throw it out and literally build a new system for thinking about quality, right from the ground up. Let's see what that looked like. And the big breakthrough was realizing that quality wasn't just one thing. You couldn't just say it's good or bad. No, it was this collection of many different, equally important characteristics. It was multidimensional. And all of a sudden, the whole conversation changed. People started asking totally new questions. Is it usable? Can a normal person actually figure this thing out? Is it maintainable? Can we fix it later without introducing 10 new bugs? Is it reliable? Is it going to crash all the time? Each one of these became a new pillar, a new way to define what good software really is.
And this new mindset led to this really cool evolution in how companies managed quality. I mean, at first it was super basic, just inspection. You'd wait till the end and then check for bugs. Then it got a little smarter with quality control, where you'd not only find the bugs but also try to figure out why they happened. The next huge leap was quality assurance, actually building processes to stop the bugs from ever happening in the first place. And that all led to what we call total quality management, where quality isn't just a department, it's part of the company culture. It's everyone's job, all the time.
So all these new ideas are great, but you need tools to actually put them into practice. So let's look at one of the most important models that came out of this whole era, one that gave developers a real, structured way to measure and achieve quality.
So in 1978, a guy named Barry Boehm comes along and introduces this model that was a total game changer. Instead of just having this vague idea of good software, his model created a hierarchy, a structure of specific, measurable things you could look at. It was like a blueprint for quality.
The whole thing is organized into 3 levels. Think of it like a pyramid. It starts with really broad, high-level ideas at the top and gets more and more specific as you go down. So let's start at the very top.
At the very top, Boehm's model asks 3 basic questions about any piece of software. First,
as is utility, which really just means, does it work well right now? Can people use it? Is it reliable? Second, maintainability. How hard is it going to be to fix this thing or update it later on? And third, portability. If we need to, can we make this software run on a new computer or in a different system?
Okay, so those are the big picture goals at the top. But how do you actually make them happen? You can't just tell a team, go make it maintainable. You need to give them concrete things to focus on. And that's where the next level of the model comes in.
And here they are. These 7 factors are the building blocks. And hey, they should look pretty familiar, right? These are the exact same ideas we were talking about earlier. Boehm's model provides that crucial structure. It shows that if you focus on things like reliability, usability, and testability, that is how you achieve those high-level goals.
But this is where the model gets really powerful. It doesn't stop there. It goes even deeper. Each one of those 7 factors is built on an even more fundamental set of ideas.
So, for example, let's just take one, testability. In Boehm's model, that's not just some vague concept. It's broken down into what he calls primitive constructs, like accessibility. Can testers even get to the code to test it? Or structuredness, how well organized is the code? It's this incredible level of detail that gives teams a real, actionable checklist for making things better.
So if there is one big idea to take away from this whole story, it's this. Software quality is not one thing. It's a complex system of interconnected parts you have to design and measure and manage right from the very beginning. The software crisis was this huge, painful moment, but from its ashes, we built the foundations of modern software quality. But as software gets woven even deeper into our lives, with AI